Okay, so I have put on here some formulas to make sure that you have memorized for the exam. They will not be given to you on there, so make sure you know these. And just to reiterate what I said in the announcements, there are 16 questions and you'll have 90 minutes to take the exam, and you may use a scientific calculator, but no notes. And make sure that you're showing all of your work right on the exam. The testing center will give you scratch paper, but that scratch paper will be thrown away. And so I like to give partial credit on exams. So make sure that you're putting on the exam anything that you want me to grade. And if you leave questions completely blank and only have an answer, you might miss all the points on there. So just make sure you've got your work shown, and that way you'll be able to earn partial credit too if you didn't get it completely right. So are there any questions about the exam, just overall, that I can answer for you before we get started into doing some review questions?
Not for me yet.
All right.
Not for me also.
Okay. Well, make sure you speak up as we're working through some of these questions and stuff tonight, that, if you need some clarification on any of them, just let me know also on that. Okay, let's see. I guess maybe just a couple of other things that I'm going to put up here in addition to these formulas. A couple of other things that you should make sure that you remember is that, what's happening with my pen? That the domain is all of the x values. Oh my goodness, my pen is really not working great. Okay, the range are the y values, and then a function is where the x values don't repeat. Right, so if something's considered a function, then those x values are not going to be.
Screen?
Oh, is it not showing? Thank you. That will be a lot easier for you to see. I am so sorry. I thought I was. There we go. Is that better? I'm so glad you spoke up. Okay. So these are just things to make sure that you have memorized, or just things to know for this second exam. Okay, so let's start working through some problems. Now, on this exam, most of the questions are going to come from Module 3 and Module 4. However, there are going to be 4 questions that come from Module 1 and Module 2. So make sure you go back over that first exam and specifically, pay attention to story problems, questions that you missed. Make sure that you know how to do them correctly now on there, because oftentimes the most missed questions are the ones that kind of show up again on that second one, that next exam, just to give you, a chance to redo and show me that you know how to do those now. Okay. All right, let's look at a few questions from Module 1 and Module 2, and then the bulk of the time will be spent, though, working on problems from Module 3 and Module 4. So one question that I saw people struggling with was solving these compound inequalities. So something that looks like this. Negative 13 is less than 2x minus 3, which is less than or equal to negative 1. And so when we're solving this, we really want to get the x by itself in the middle. Now, sometimes you get it explained to you, to set these up as two different inequalities, and you can do it that way, but I think it actually makes it harder that way, and I'll show you why when I work through this. So let's work on getting x by itself in the middle. So that means first thing I need to move is that subtract 3. So that means I'm going to add 3 to all of the different parts here, right? All 3 parts. This is called a tripartite because it has 3 parts, and so that's important to do. So that the 3's are gone there now in the middle. On the left, we're left with negative 10 is less than 2x, which is less than or equal to negative 1 plus 3 is positive 2. And now 2 is connected to x by multiplication, so to undo that, let's divide all 3 parts by 2. And so when I do that, I get negative 5 here is less than x, which is less than or equal to 1. So the way I read that is a perfectly good way to read it, but really what this says is x is between negative 5 and 1, including 1. So when you're thinking about what that is, and you're thinking about a number line that we're dealing with here, right, because it's going to tell you to solve it, graph it, put your answer in interval notation. So negative 5 is here, 1 is somewhere down here, and I can see that I have next to my negative 5, I have a less than, and so that's going to be an open circle on that one. And next to my 1, I have a less than or equal to, so that's a closed-in circle there. And then we want all of the stuff that's between it. And so the stuff that is between it is this. All right, and so these compound statements like this are always and statements, and so we are looking for the overlap. And so that's what we are doing here. And so that means our answer in interval notation will be parenthesis, negative 5, 1, bracket. And so just, if that was something that you struggled with last time, maybe just, work on a few more of those and make sure you know how to do it. Another one that was missed a lot is solving equations that have fractions in them. So let's look at one like that. So this one says 1/3 y minus 10 equals 1/7 y. So when I'm solving something like this, for me, I think it's easiest to get rid of the denominators, like kill off the fractions, because usually when students make mistakes on this, it's because of the fraction rules. And so the way that you can kill off the denominators here is by multiplying each part by the LCD. So we can see that we've got a denominator of 3, here are denominators 1, and here are denominators 7. And we can always find a common denominator by multiplying the denominators together. So 3 times 1 times 7 is 21. And in this case, it is the least common multiple of all three of those numbers as well. And so now what I want to do is multiply each part by 21. So I'm going to put this as 21 over 1, just so it's easier for me to keep track of my fractions here. This one I'll multiply by 21, and this one also by 21 over 1. And then what happens here is we are killing off the denominators. So I can see that 3 divides into 21 7 times, and then I have 7 times 1 times y is 7y. And so now I have no denominator left. I killed it off, right, just to make it easier to solve here. All right, on this next one, there's only a 1 in the denominator, so there's nothing I need to kill off there, so I'll just multiply those together. Negative 10 times 21 is negative 210. And then on this one, 7 divides into 21 3 times. 1 times y times 3 is 3y. And now from here, that's not so bad, right? It looks pretty easy to solve from here. So let's get all of the y's on one side so we can solve it. So I'm going to choose to subtract 7 over. So that's going to give me negative 210 equals negative 4y. And then I just need to divide by negative 4. And if it tells you to, leave your answer as a fraction or a decimal, usually it doesn't matter to me which way you leave your answer. So if it wanted it as a reduced fraction, well, 2 can divide into both of those, and they're both negative, so it's going to end up being positive. So I can say y equals 105 over 2. Or if you change it to a decimal, just put in your calculator negative 210 divided by negative 4, you would get y equals 52.5. Okay, and so like I said, you get full points for either of those questions. Okay? Or sorry, either of those answers on there, unless it's specified which way you need to give your answer. All right, let's look at just one more from just one of the most missed problems on the last exam was something like this. It was an absolute value inequality. So this one, let's do the absolute value of 4x plus 1 is greater than 3. So with absolute value, we don't know whether we have whether we're dealing with a positive case or negative case. So we need to look at both of those. And what I mean by that is if you take the absolute value of negative 3, it's 3 because negative 3 is 3 places away from 0 on the number line. But if you take the absolute value of positive 3, the answer is still 3 because positive 3 is 3 places away from 0 on the number line. So there's 2 different ways here that we can get the same answer. So when we're dealing with absolute value, we got to remember that we're going to be writing 2 statements. And I'd say that that is probably the place that most students, if they made mistakes on this, it was because they forgot to write the 2 statements. So the first one is going to be just like we have here without the absolute value. So 4x plus 1 is greater than 3. And then we're going to have 4x plus 1. We'll flip the inequality sign. So instead of be greater than, now it's going to be less than. I'm going to put it in a different color there to make sure it stands out. And then we need to change that 3 to the opposite. So it's going to be negative 3. Okay. And then you'll just solve each of these down. Now before I do that, there's something else that I want to point out to you here. So So I use a play on words to help us figure out whether we're dealing with an and or an or statement. And so since this is a greater than, then I say to think of it as greater. All right, so it's an or statement that we're going to be dealing with here. If it was less than, then I want you to think of less than. So just a little way to help you remember whether you were dealing with an and or an or statement, because that changes our answer completely depending on whether it's an and or an or. Okay, so now let's solve each of these down the rest of the way. So I'll subtract 1 over at 4x is greater than 2, divide by 4, so x is greater than 1/2. And then on this one, let's subtract the 1 over, so I get 4x is less than -4. And now I need to divide both sides by 4, so x is less than -1. And then again, on these, they don't tell you that you have to graph them, but I think it's in your best interest if you do, just to make sure that you are giving the correct answer. So if I graph this on here, so -1 would be somewhere here, and then 1/2 is going to be to the right of that, somewhere, right? And so if I'm looking at each of these, I'm going to do these in different colors, make it kind of stand out. So x is greater than 1/2. So I have an open circle at 1/2, and greater than is everything bigger than it. And then I have x is less than -1. So again, an open circle there, and everything smaller than it. And so I can see that since I am dealing with, like, I want an or statement, so that's everywhere the blue graph shows up and everywhere the green graph shows up. So my answer is going to be, this is going to go clear out to -infinity, so -infinity to -1, parenthesis, because it's an open circle, but that's not all, so I put a union to say there's more, and then parenthesis 1/2 to +infinity. That's where that's going to go out to. And so that would be your answer there. Okay, any questions on those first 3 from the first exam, that Module 1 and Module 2?
I do have a question. I wrote it down, but I just need to make sure that I understood. Where you wrote like that trick of looking at the sign.
Yeah.
So if it is, if x is greater, is that how you read it? If x is greater.
Right here?
Yes. Then it would be the or union, which is what we have.
Yep.
And if the x, the sign will be less than, then the end result has to be n or intersection.
That is correct.
Cool. Thank you.
Yep, that's exactly right. Okay, yep, and again, it's just a play on words to kind of help you remember whether you're looking for the union or the intersection. So that is exactly right. Okay, well, let's work through some other ones then, some things from Module 3 and Module 4. And if you have questions, come up that you're like, oh yeah, I remember struggling with something like this, or if you have a question, specifically you want to give me to work through, I'm more than happy to do that. Okay, so on this one, we're given a function like f of x equals 3 minus 5 times the absolute value of 2x plus 1. Now, this is a question that a lot of students were struggling with, and I made a video to help. Hopefully, you guys saw those if you were struggling with these type. All right, so it gives us a function like this, and then it asks us to find f of -4. All right, so what this is telling us is that we need to put -4 in place of x in our function, and then we're just going to evaluate that. So use like order of operations to figure out what the answer is. So I'll have 3 minus 5 times the absolute value of 2, and then in place of that x, I'm going to put negative 4. Right? So I take out the variable and put that number in place of it. So negative 4 plus 1, and then the end of the absolute values. So now you've got to be careful with this and make sure that you're following the order of operations. So absolute values are like grouping symbols. They are grouping symbols. So we have to do what's inside that first. It's like parentheses. We do what's inside parentheses, you know, before we do like multiply, divide, add, or subtract. So here, right, if we write this down, so we're not doing anything with this yet. And this is where most people made a mistake, as they were trying to do 3 minus 5 first, but we can't start off doing our subtraction. We've got other things here that we need to do first. So 2 times negative 4 is going to be negative 8 plus 1. And then negative 8 plus 1 is negative 7. So absolute value of negative 7 is positive 7. Whoops. So now I'm going to have, what's going on here? 3 minus 5. And then instead of this, so the absolute value of negative 7 is positive 7. So I'm going to put that in parentheses there by it now so I remember. And now I've got to do my multiplication. So 3 minus 5 times 7 is 35, so minus 35. And then 3 minus 35 is negative 32. And so that's what I'll have for my answer there. So just plug in what they give us, you know, f of whatever is basically saying this is the x value that I need to put in place of the x in the function. Okay. All right, let's see. Let's look at some problems where we're dealing with some graphing, lines, and slope and stuff like that. There was a lot of that on this one. So let's do, so it wants us to graph negative 3x plus 4y equals negative 12. And there's a couple of different ways you could do this, and so I'm going to show you 2 different ways, and then you just use whichever way works best for you. You know, if it tells you that it wants you to graph it using intercepts, then make sure you do it that way. If it just says graph and it doesn't tell you, you know, how to do it, then any way you want to do it is fine. So if we're graphing using intercepts, then remember, if we are trying to find our x-intercept, we're going to let y equal 0 and then figure out what x is. All right, so this is going to end up being my x-intercept when I do this. And then to find my y-intercept, I'm going to let x equal 0, and then I got to figure out what y is. So that's how I would find my y-intercept. Okay, so let's do that using this formula up here, this equation up here. So let's find our x-intercept first. So I'm going to have negative 3x plus 4 times 0, right? I'm putting 0 in place of my y here. And then equals negative 12. Well, 4 times 0 is just 0, so that term's really gone. And then I have negative 3x equals negative 12, so now I just need to divide both sides by negative 3. So x equals positive 4. Okay, now when it asks for you to write intercepts, make sure like intercepts are a point. All right, so this is the point blank comma 0. right? That y is always 0. And we just found our x to be 4. So writing that as an ordered pair, we would say that this is the point 4, 0. That would be my x-intercept. Okay, and then similarly, to find the y-intercept, let's now put 0 in place of x on this. So now I'll have -3 times 0, so putting 0 in place of my x there, plus 4y equals -12. And 3 times 0 is just 0, so that term is gone. And then all I have left to do is divide by 4, so y equals -3. And again, if I write that as an ordered pair, right, we let x be 0, so 0, -3 is my point on that. Okay, so now if I go and graph it, right, I'm using these 2 points to graph it. So I'll do that here. So over 0 down 3 is going to be here. And then over 4 up 0 is here. And then we're just connecting those 2 dots together to make our line. Okay, so that's one way that you can do it, and to graph it, using intercepts. And the other way that you can do it is graphing by putting equation in the y equals mx plus b form. So basically solving our equation to get y by itself. So let me write our equation down here again. So -3x plus 4y equals -12. Right? And so I'm trying to get it so that the y is by itself. So I'll start by adding the 3x over. So now I'll have 4y equals 3x minus 12. And then I just need to divide everything by 4. That will give me y equals 3/4 x minus 3. So remember, in slope-intercept form, right, this number right here, that -3, is the y-intercept, which is what I found over here, right, by plugging 0 in place of the x and finding the y. But when it's written in slope-intercept form, I can just pick it out right there. And so when I'm graphing this way, I'll start with that y-intercept. So I'm going to go down 3 on the y-axis, and then from there I need to do the slope, rise over run. So up 3 and then right 4, and then that will be the line again, right? So same question here, just different ways to go about getting to it to be able to graph it, but you'll have exactly the same line. It's just kind of preference if it doesn't ask you which way you want to do it, or which way you need to do it. Okay. Any questions you have? Make sure you're speaking up. I love it when you're asking questions, so please don't be afraid to speak up. Okay, so let's graph something else, but this time we're going to be graphing a linear inequality. So I've got -2x plus y is greater than or equal to -2. So for me, whenever I'm dealing with inequalities, I like to solve it and get y by itself on the left side. And then that just makes it easier for me to graph it. So basically on this one, I need to start by adding my 2x over so that I can get that y by itself, right? So here I've got y is greater than or equal to 2x minus 2. And so if I graph this the same way I did up here on that second way, we'd start with our y-intercept, which is negative 2. So on the y-axis, go down 2. And then from there, I'm going to go up 2 and over 1, right? I've got to have that rise over run as a fraction. And so if a fraction isn't given, then make sure you put a 1 underneath it to make it into a fraction. So I'll go up 2 over 1, or I could go down 2 and to the left 1. Okay, and now I need to look at this inequality, and it is a greater than or equal to, so it is going to be a solid line on this, but if it didn't have the equal to part, then it would be a dotted line. So watch that closely on when you're doing this one. It is so easy to forget to look for that, whether it's a dotted line or solid line. Just kind of used to drawing solid lines. All right, and then that's not all. Then we got to figure out the shading of it. So one side or the other of the line is going to be shaded, and the way I like to look at it is so I found this line, but I want the stuff that is greater than or equal to. Well, I've got the equal to part by showing it's a solid line. The stuff greater than it is going to be above the line. So that would be all of this stuff. So the shaded part would be here. All right, so if it is a greater than or equal to, then you'll shade above the line. And if it is a less than or equal to, then you'll shade below the line. So on the videos, they have you, do test points and stuff like that. And you can do it that way, but you don't have to. I'm not giving you any points for, doing it that way. If you understand this and can see, oh yeah, if it's greater than, then I want the stuff above the line. If it's less than, then I want the stuff below the line. Does that make sense?
Yes.
Okay. Sometimes some people are like, yeah, I see it, and other times people are like, I don't really see it. And if you don't see what I'm saying there, then I would just say, well, then just do your test points like you did on your homework, and that's totally fine. Whatever is going to work best for you is what I want you to do. Okay. All right, let's try another one here. So this one's kind of a little story problem of sorts. So I don't even know which question I'm on now. Am I on 7? Okay. Okay, so on this one, it says Guadalupe rides her bike for 2 hours. And is 18 miles from her house. After riding 5 hours, that's a long bike ride. After riding 5 hours, she is 42 miles away. What is Guadalupe's average rate of change? So when it's asking you for average rate of change, that's basically telling you to find the slope. All right. And so when we're trying to find the slope, well, we can find the slope between 2 points, but right here, these are not written as, as ordered pairs, but we can change it to make them so that they're written as ordered pairs. So remember that, so we're trying to find here like miles per hour is going to be that rate that we're looking for, right? So I'm going to write that over here. So we want to find the miles per hour. Whoops. Didn't mean to put that. And so when I'm writing down my two different points on this, my miles need to be my y's and my hours need to be my x's. Okay, so I should be writing it in the form of hours, comma, miles. Because remember, with our slope formula, let me put that over here too. So our slope formula is y equals, sorry, I meant m equals, goodness, I'm struggling here. M equals y2 minus y1 over x2 minus x1. So notice our y's are on the top and our x's are on the bottom, and that is the way it has to be. You can't flip-flop these, otherwise your slope's going to be upside down, right? So y's need to be on top, x's need to be on bottom, because we're doing a rise over our run. So our y's are what moves us up and down on our graph, and x's are what move us left and right. So remember that rise over run should help with it. Okay, so let's look at this first one. So 2 hours in 18 miles. All right, so on this one, my first point is going to be 2, 18. And then the second point is 5 hours and 42 miles. So I'll have 5, 42. And so now I have my two different points that I'm trying to set up, and then I can just kind of label these. So here's my x and y of my first point, so I'll label this as x1 and y1. And this is my second point with an x and y, so x2 and y2. And now I just need to plug those into that slope formula to figure this out. All right, so I'll have m equals y2 minus y1, so 42 minus 18 over my x2 minus x1, which is 5 minus 2. All right, and then we should subtract those on the top. 42 minus 18 is 24, and then 5 minus 2 is 3. And so if I divide those out, 24 divided by 3 is 8. But 8 what? Remember, we're looking for an average rate of change, right? And we're talking about miles per hour. So 8 miles per hour is the average rate of change. Okay, and so remember, to find that average rate of change, you're just using this slope formula. Okay, make sure you have that memorized. All right, any other questions that have popped in your mind?
Not so far.
Okay. Okay. All right, so one thing that I want to make sure that you know how to do, one thing that is always shows up on the exam, is about writing equations of lines. And they'll give you different information, and so you have to know how to use that information to write an equation of a line. So let's look at one like this first. So if I ask you to find the equation of a line with the slope of positive 6/5 and passing through the point -5, -4. All right, and then it wants you to write your answer in that slope-intercept form, that y equals mx plus b form. So whenever it's telling you to find an equation of a line, I mean, one way that you can always do this is to use that point-slope formula. It's not the only way you can do it, but this is a way that you can always do it. So the point-slope formula says y minus y1 equals m times x minus x1. And it's called the point-slope formula because you need a point, the x1, y1, and the slope in order to write that. And that's exactly what we're given here, right? We're given the slope, we're given a point, or x1, y1, and so now I just need to plug that in there to write that equation of a line. Sometimes it throws people off because they're like, what about that x and that y? Well, in equations, we have an x and a y. We're not putting numbers in for everything. I mean, remember back up here when we were dealing with these equations, right? We still had a y and an x left in there because those are our variables, and depending on what we put in there is going to give us different points along the line. Because all they're giving us on this is just one of those points that's on the line, but there are an infinite amount of points on that line. This is just one of them. Okay, so let's go ahead and put that in. So I have y minus y1, which is -4. So be really careful with this. We're doing y minus a -4 equals m. Whoops. And what is my m? My m is 6/5. Let's put that in. Times, so parentheses, x minus a -5. So watch your signs closely on this. I would say the most common mistake I see with this is people write this as y minus 4 and x minus 5 when it should be minus a -4 minus a -5. All right, so if I'm minusing a negative, that's really adding. So I end up here with y plus 4 equals, and again over here, minusing a negative is really adding those. And so now I'm going to distribute that 6/5 through. 6/5 times x is 6/5 x. And then 6/5 times 5. All right, if you're not quite sure, you can just do a little side work. 6/5 times 5 over 1. And then you can see that those 5s divide out, or some people just like to multiply across the top, multiply across the bottom. 3 times 5 is 30. 5 times 1 is 5. 30 divided by 5 is 6. All right, so that's what I'm going to be putting here. So 6/5 x plus 6. And then last thing I need to do is get the y by itself, so let's just subtract the 4 over, and then I will be done. So y equals 6/5 x plus 2. And that is our answer. So that is the equation of a line that has a slope of 6/5 and goes through that point, -5, -4. And that's what we're looking for our answer. Okay, let's do one other one here. And so remember at the back at the beginning where I had written down that if lines have the same slope, if they're parallel lines, they have the same slope. If they're perpendicular lines, the slopes are opposite reciprocals. Okay, and so that's going to come into play on this next one here. So if I ask you to find an equation of a line that is perpendicular to the line y equals 1/4 x plus 4, and through the point 2, -11. Okay. So again, if I'm trying to use that formula, the point slope formula, right? We've got y minus y1 equals m times x minus x1. Okay, now I'm given a point, so I have my x1 and my y1, but I don't have my slope quite yet. All right, I can see that this number in front of the x, as long as it's in slope-intercept form, that y equals mx plus b form, then the number in front of my x is my slope, but I want it perpendicular to that. So that means I need to flip it and change the sign. So I've got to do both, right? So the perpendicular slope would be what?
-4.
Yeah, -4, right? Because I flip it, get 4/1, and then change the sign to the negative. Okay, so this is what I want to use this time. So slope is -4, and there's my point. So, and then from there, it's pretty much the same thing that we did before. So y minus -11 equals m, which we found to be -4, times x minus x1, which is 2. Okay, and again, minusing a negative is really adding here. So I've got y plus 11 equals, let's distribute that -4 through, so -4x plus 8. And then last thing we need to do is subtract the 11 over. So y equals -4x minus 3. Okay. And other things on your homework that they asked you, sometimes they gave you 2 points and asked you to find the equation of a line that goes through 2 points. Well, if they're giving you 2 points, then you could use the slope formula to find the slope, and then one of the points, right, to put into the equation. So just think about what is it that you're given and how can you use what you're given to find the equation of a line. Okay. So definitely there will be some like that on there. Okay, well, let's get into some stuff from the last module, well, module 4, last one that you did there. And so a lot of this was, solving systems of equations. And so you talked about, you learned about how you can solve things using substitution, or solve things using the elimination method, or you could solve things by graphing. So there's, multiple different ways that you can solve these. So I want you to, on this first one, let's solve the system by graphing. So if it gives you 2 different lines here, so y equals 2x minus 3, and then x plus 2y equals 4. Okay, so actually put a little squiggly bracket around it just to show you it's a system, that we're graphing these together on the same grid, and we're trying to figure out where is the point that those 2 lines are crossing. So for me, again, there's more than one right way you can graph these, but I like to get it into y equals mx plus b form. So I can see that this top one is already in that form, so great, but the bottom one I need to get y by itself. So I'm going to start by subtracting my x over. So that will give me 2y equals negative x plus 4. And then I need to divide everything by 2. So I'll get y equals negative 1/2 x. And then 4 divided by 2 is 2, so plus 2. Okay, and now let's go ahead and graph these two lines. And I'll just graph them in different colors just to make it easier to tell which one is what. Okay, so let me put my little markings. So on the first one, start with my negative 3 because that's my y-intercept. So I'll have a point here, and then from there, my rise over run 2 over 1. So up 2 over 1, up 2 over 1. Or you could go down 2 and left 1, right? Any of those will just go across there. So I will that. And then let's graph the other one. I'll graph this one in green, so hopefully you can see the difference here. So my y-intercept this time is positive 2, so on my y-axis I'll go up 2 places. And then my slope from there is telling me go down 1 and right 2. So down 1 and right 2, those are going to cross right there, it looks like. All right, oops. It's so hard to draw these on this, but oops, that still didn't quite work, but I think you get the idea. So the point in which these two cross each other is going to be the point 2, 1. And my graph is not great, but on the test you'll have a grid and everything that's all to scale, so it'll be a little bit easier to see that. But that would be my answer, is the point in which those two lines cross each other is at the point 2, 1. So that is my answer for it. Okay, and then the other ways that talked about is by solving things with substitution or solving things with elimination. Now on the test, it does tell you on 2 of them, one tells you to solve by substitution, the other one by elimination. If you don't solve them in the way that is asked for, you will miss some points there. But if you're struggling to figure it out the way that it was being asked, then definitely, solve it using the other method so that you can get some points on there, right? But look for those instructions and make sure to follow those to get full points. Okay, so my first equation says x minus 5y equals negative 54. And my second equation says y equals negative 3x minus 2. Okay, so again, that's my system. And to solve something by substitution, it's actually nice if we already have one of our variables by itself, which we do on this bottom one, right? Y equals all of this stuff. And so that means I can take all of this, that negative 3x minus 2, and substitute it in place of y in that first equation. So when I do that, I'll have x minus 5, and then times negative 3x minus 2, and then equals negative 54. All right, and now I only have x's to solve for, and so that's why I do that substitution, so that I can solve for one of those variables. All right, so it looks like on here, first of all, I need to distribute that negative 5 through, so I've got x, and negative 5 times negative 3 is going to be positive 15x, and then negative 5 times negative 2 is positive 10, and equals negative 54. Let's get our x's together. So that's 16x. And then I need to subtract that 10 over. So 16x equals negative 64. And now I just need to divide by 16. So put that in your calculator. Negative 64 divided by 16 is going to give us a negative 4. Okay, but I'm not done yet. Sometimes on the test, people just get rushing and they stop there, right? This is part of my answer, but remember, when I'm solving a system, I'm trying to find the point in which they intersect. So I found my x coordinate, but now I need to find my y coordinate. So I can take that x equals negative 4, and I'm going to substitute that in. You could put it into either of the two equations, but I'm going to put it into this bottom one here because y is already by itself there, so it looks easiest to me to do that. But either one would work. You could put it in the top one and still get the same answer. So y equals negative 3 times negative 4 minus 2. So y equals negative 3 times negative 4 is positive 12, minus 2 is going to give me positive 10. So the point in which these two lines cross each other is at the point negative 4, comma 10. All right, and that would be your answer. All right, questions so far?
I have a question.
Yeah.
For the elimination one, could we go over a question that is like the kind where you multiply?
Yeah.
Yeah, you multiply a number on both equations, because sometimes when I do it, I get a fraction, and I don't, and it's not looking for a fraction.
Yeah.
I don't know how that happens.
Yeah, and I'll tell you right now that on these solving, the systems of equations, all of the answers on the exam are going to be integers. So they're not going to be fractions or decimals. So if you're coming up with a fraction or a decimal, then you have done something wrong. So make sure that you go back and check over your work. On the homework, you had some fractions that sometimes were your answers. But on the test, I'm just going to give you a little hint that those should all come out to be whole number answers, not fraction answers. Okay, so yeah, that's a good thing to look at here. So let's try this one with our solving by substitution. Oh, sorry, I mean solve using elimination. Okay, I don't remember which number I'm on. Hopefully it's 11, but I can't remember. So I'm just kind of jumping around and picking out some questions here. All right, so this one says 2x minus 4y equals 2. And then the second equation says negative 3x plus 6y equals 6. So first thing you need to decide is, are you going to try and eliminate the x's first or the y's first? And sometimes there's, one is easier than the other, and so you can do that. But on this one, it's probably about the same. It doesn't look like it's really easy. And what I mean by easy is, like, maybe you would only have to multiply one equation by something to get one of those variables to eliminate. But on this one, so say that I was looking to eliminate my x's first. Well, the easiest way to go about doing this is thinking about, okay, well, I've got a 2x and a negative 3x. So if I multiply this top equation by 3, by a positive 3, right? That's going to give me 3 times 2x is 6x. And then if I multiply the bottom equation by 2, 2 times negative 3 is negative 6. So that's going to make those eliminate out. So you're kind of like using the coefficients, you know, in front of those x's to try and figure out. But one needs to be positive and one needs to be negative. And so if both of these were positive to start off with, then I'd need to multiply one of the equations by a negative. But we already have a positive and a negative here, so this will work out fine for us. So let's go ahead and multiply that through and see what we come up with here, right? So I've got 3 times 2x is 6x. 3 times negative 4y is negative 12y. And then 3 times 2 is 6, so equals 6. And now let's do the same thing on that bottom equation, distributing that through. 2 times negative 3 is negative 6x. 2 times 6y is 12y, so plus 12y. And then 2 times positive 6 is positive 12. All right, now something kind of funky happens on this one. All right, when I'm adding these together, I see, well, I've got 6x minus 6x, so that is gone, right? The x's eliminate out completely. And the same thing happened here with my y's. Negative 12y plus 12y is 0. So what I end up with is 0 on this side equals 6 plus 12, which is 18. Well, 0 doesn't equal 18, right? That's untrue, right? This is not true. And so if you come up with something like this, that where the x's and y's eliminate out, and you end up with a statement that is not true, then that means it's a no solution. If you came up with something like, 0 equals 0, that is a true statement, then you'd have infinite solutions would be your answer. Okay? Or if it was like 18 equals 18, just as long as it's a true statement, that would be infinite solutions. But if it's not true, then it's a no solution on this. Okay? And I want to do some story problems. And on the story problems, we're going to do one with the elimination method also. So we could kind of look at that one. Unless there was a specific one that you wanted to work through.
I have a specific question.
Okay, yeah.
It's elimination still.
Great, let's do it.
Okay. This one is 5x minus 3y equals 22.
Okay.
And then 3x minus 2y equals 13.
Okay. So, you tell me, which variable do you want to try and eliminate first? Do you want to get rid of the x's or do you want to get rid of the y's first?
Wait, I need to pull up my notes so I can see what I did really fast.
Well, just tell me what you're thinking here. It doesn't, I mean, you can pull up your notes, but I just want to see what your thoughts are.
Okay, give me 1 second. Okay, I think I'm gonna go for 5x and 3x.
Okay. So what would you multiply each of these by? What do you want to multiply the top equation by?
I want to multiply it by -3.
Okay. And how about the bottom equation?
5.
Yeah. All right, because that's going to give us negative 15x on the top and positive 15x on the bottom. So that will eliminate out. So that looks great. Okay, so let's try these. So if we're distributing this through, let's see, what do we get here, right? So negative 3 times 5x is negative 15x. Negative 3 times negative 3y is positive 9y. And then negative 3 times 22 is going to be, so equals negative 66. All right, we good there?
Yes.
Okay, and then on the bottom, let's now distribute that 5 through to everybody. So I'll get 15x, and I'll get negative 10y, and then I'll get 5 times 13 gives us what? Positive 65. Is that what you came up with? Are we okay to that point?
Yes.
Okay. So now, right, we can see, I mean, we made those x's eliminate. That's what we were trying to do, and we did that. They're gone. And now I'm left with 9y minus 10y is negative 1y equals negative 65 plus 65 is negative 1. And so now, to get y by itself, I just need to divide by negative 1. So y equals positive 1. So 1 is going to be my y. And then how am I going to figure out what x is?
By plugging it in.
Yeah. And does it matter which one I use?
It doesn't.
No. So, I mean, I look at the bottom equation. I always want to go back to the original equations, the ones that I have in black here. And those just have smaller numbers, so I probably would choose this one, but, you know, either one would work. So if I do that, 3x minus 2 times 1, because that's what we said y is, right? So I'm putting 1 in place of my y there, and then equals 13. So 3x minus 2 equals 13. Let's add the 2 over. So I get 3x equals 15. And then divide by 3. So x equals positive 5. So the point in which these two lines cross is at the point 5, comma 1. And that would be my answer. Does that make sense?
Yes, thank you.
You're so welcome. Thanks for asking. It's a good one to look at. Sure. Okay, I think though I want to focus on some story problems, so let's do a couple of story problems on these. You know, the different types of story problems that you had on your homework. There were mixture problems, right, where you were mixing like either solutions together, or you mixed like nuts and chocolate together to make some kind of a trail mix, or, you know, stuff like that. And then there was also like those distance equals rate times time problems where you're dealing with an airplane or a boat. And then there were other ones where it's like tickets, right? Where it's just like, you know, you go to a fair and, you know, or a movie or something like that, and tickets cost this much for adults, this much for kids, and stuff like that. So those are kind of the main types of story problems that showed up on these systems of equations. So let's work through a couple of them here. So this first one, let's see. How many pounds of chocolate costing $15.20 per pound. Should be mixed with nuts costing $3.10 per pound. To create a 28-pound mixture. Okay, that is worth, or that costs, $9.45 per pound. And then make sure on this that you're rounding, you know, like if it tells you a certain place to round to, like on this one, I want you to round to the nearest pound or the nearest whole number is what we're looking for. Okay, but sometimes it might be, you know, round to the nearest tenth or round to the nearest hundredth. So make sure you're watching those directions closely too. Okay, so when I'm dealing with mixture problems, I like to set it up in a chart to help me organize the information, because there's a lot of information in there. And it would be easy to kind of get lost in everything that it's saying there. So what I like to do is I like to put at the, you know, at the top of this, the different things that I'm mixing together. So I'm mixing the chocolate and I'm mixing the nuts and then my total. All right, so that total mixture. And then down the side, I'm looking for like the labels or units in it, in the question. So it's giving me things about pounds. So I know that's going to be one thing I want there. And then the other thing is these dollar signs, all right? So it's talking about the cost. And then also I'm dealing with the total. Okay, so now I'm just going to fill these in so I can see what I'm dealing with here. All right, so when I'm looking at the, you know, the pounds, like how many pounds of chocolate and nuts do I need? Well, that's what it's asking for here. So you always want to, you know, define your variables. Let's see, use a different, no. So let's define our variables. So I'm going to say X is the chocolate, or more specifically, the pounds of chocolate. And Y is the pounds of nuts. Okay. And so I don't know what either of those are. So I need to put those variables in there, the X and the Y. But I do know the total pounds that it's telling me I want to mix is 28. So that's going to go in the total here. All right, then with the money, right, I know that the chocolate costs $15.20 per pound. Let's see. The nuts cost $3.10 per pound. And then on this one, the total cost per pound, right? I want it to be, we want to charge $9.45 a pound. Okay, and then on this last line, to find this last row here, to the total, I'm just multiplying those first two rows together. So X times the 1520, so 1520X. And then 310Y right? $3.10 times y, and then 28 times 945, 9.45. And now these are going to give me my two equations. Okay, so this top one, this top line is my first equation, and this bottom line is my second equation. So my first equation is just going to be x plus y equals 28. And then my second equation is going to be 15.2x plus 3.1y equals, let's see, 28 times 9.45. What is that?
18.3.
I
8.
got 264.5.
Yeah. So
mine went to 264.6.
What transaction did you do again?
yeah, it should be 264.6, I think.
Oh,
Try looking at that again. So 9.45
Oh, yeah.
times 28.
I just looked at it wrong.
That's okay, yeah. No worries. Okay, does somebody have a question on that though, or does everybody see how we got those numbers?
What was the bottom transaction again that you do?
How did I get this bottom row?
The 264.6.
Are you asking how did I get that?
Yeah.
I multiplied the 28 and the 9.5.
Cool. Thank you.
So I'm always just multiplying the two rows together to get that last row. Okay. All right, and then from here you could either solve this using substitution or elimination. For me, it looks pretty easy to get one of our variables by itself here, like to get y by itself, I could just subtract an x over. All right, so I'm going to change this to be y equals 28 minus x. And now, since I have one of the variables by itself, the y by itself, now I can put that 28 minus x in place of my y down here. Okay, now on the homework, well, I guess it was on the last test where you were dealing with like equations with decimals in them and stuff like that. Yeah, you could get rid of the decimals by multiplying, that whole bottom equation by 10, but you don't have to do that. You have a calculator to use, and so it doesn't seem like it makes it much easier, to me, if we're doing that or not. And sometimes students get more confused by that. So let's just put this in here. So that's going to give me 15.2 x plus 3.1 times 28 minus x equals 264.6. Okay, so now we need to distribute that 3.1 through. So 15.2x plus, what's 3.1 times 28?
It's 86.8.
Okay, so 86.8. And then 3.1 times negative x is going to be minus 3.1x. And then still equals 264.6. All right, let's get like terms together. All right, I can see I've got 15.2x and a negative 3.1 that I need to get together. So what's 15.2 minus 3.1?
It's 12.1.
Yep. So 12.1x plus 86.8 equals 264.6. Now let's subtract that 86.8 over. And definitely use your calculator to help you on this. I know sometimes people are, it's just so easy to make little mistakes. So double check it with your calculator. right, when you have all these decimals. So what's 264.6 minus 86.8?
177.8.
Okay. And now what we'll have to do is just divide by 12.1. And so what does that give us? X equals, and this doesn't come out to a whole number answer, right? What do we...
14.69.
Okay, and so if it asks us to round to the nearest pound, right, then that 6 is big enough to round that 4 up to a 5. So we're going to say X is 15 pounds of what? What was our X again?
Chocolate.
Yeah, so 15 pounds of chocolate. Whoops. Got the O and the L backwards there. Okay, chocolate. And then what do I need to do to find the pounds of nuts?
You can plug it in from that X plus Y equals 28.
Yeah. And I mean, you could go to this one where we got Y by itself already, right? So we're really just doing, yeah, but either way, you're going to get the same thing. Y equals 28 minus 15. So Y is going to give us 13 pounds of nuts. Okay. And make sure you remember word questions need word answers. So make sure you put all your labels on there and tell me what it is you found, like 15 pounds of chocolate, 13 pounds of nuts. All right. Okay, we're going to do one more here, and then we'll be done unless you have other questions that you want to look at. So let's do one of those like airplane problems. So this one says an airplane travels 1,400 miles in 5 hours with the wind. Okay. The return trip against the wind takes 7 hours. What is the speed of the wind and the speed of the plane in still air? All right, so the two things that we're trying to find, right, is the speed of the wind and the speed of the plane. So again, I like to make sure I'm identifying my variables here. So I'm going to have W is going to represent the speed of the wind, and P, I'm going to be the speed of the plane. Okay, and that's in still air. Okay, so I, again, like to set these up as a little table. You don't have to set it up as tables. Some students like, I don't like setting it up in tables. That's totally fine with me. Whatever works best for your brain is always what I want you to use. But sometimes some students do like it just to be able to organize their information a little bit better. So we can tell that this is a distance equals rate times time problem because they're giving us information about distance, rates, and times. All right, and so that's what's kind of standing out to me there. So distance equals rate times time. Now it's also giving me information about what's happening with the wind and what's happening against the wind. Okay, and so those are going to be my two different equations. One is what's happening with the wind, one that's against the wind. Okay, so let's look and see here. What is my distance with the wind?
1,400 miles.
1,400. And how about my distance against the wind?
That's what I'm trying to find out.
So it says the return trip. So on a return trip, that means you're doing the same thing just in reverse, right? So you're still going that same amount. You're still going 1,400 miles, just in the opposite direction. Okay. Now we don't know the rate here, but we have information about the hours. So I'm going to have with the wind takes 5 hours and against the wind takes 7 hours. So think about this, right? If it's with the wind, then that plane is actually being pushed faster than what it's really going. And so that's why you can get there faster, why it only takes 5 hours. Where if you're going against the wind, then that is like, that's coming, you know, in the front of the plane and it's slowing that plane down. They also call that a headwind because it's like, you know, it's the plane is actually having to work a little bit harder to go against the wind. Okay, but this part right here, this rate, is where a lot of students get a little bit confused. So watch this carefully. So the rate, all right, is made up of two different things. It's made up of the speed of the plane. So we just put plane speed. And then plus or minus the wind speed. All right, because if the plane is going with the wind, then it's pushing that plane faster. Where if it's going against the wind, we use that minus because that's slowing it down. Okay, but you've got to know that it's the plane speed and the wind speed that we're looking for. So with the wind, all right, that's making you go faster. So we'll say this is P plus W. And where against the wind, it's slowing you down. So the plane speed minus however fast the wind is because it's slowing you down that much. Okay, and then from here we can set up our two equations. So remember we have distance equals rate times time. All right, so if I set these up, I'm going to have my first equation, 1,400 equals, and I'm going to write it like this, 5 times P plus W. All right, just because it looks better to me to have that 5 on this side of it, and in multiplication, it doesn't matter the order you do those in. And then against the wind, I've got 1,400 equals 7 times P minus W. Okay, so from here, there's a couple of different things you could do. Some students think, you know, they just automatically think, well, let's just distribute that 5 through here and distribute the 7 through here. And that will totally work. Okay, however, I want you to think about this. An easier way to get there, but you don't have to do it this way, is that you can, remember this is connected by multiplication, 5 times all of this. So if I wanted to undo multiplying by 5, I would divide by 5. Right? And then 1,400 divided by 5 gives me 280. So that gives me 280 equals, those 5s divide out, and then I'm just left with P plus W. Okay, and then similarly over here, this is timesing by 7, and so to undo timesing by 7, I can divide both sides by 7. And when I do that, 1,400 divided by 7 is 200 equals P minus W. Okay, let me stop right there a second and make sure everybody's with me on what I did. And like I said, if it's easier for your brain just to distribute the 5 through, distribute the 7 through, and then solve it that way, you'll still get the same answer. Okay, this is just going to be faster. And the reason why it's faster, because look at, now when I set these up underneath each other, I don't have to multiply the equations by anything. I can see using the elimination method, these W's are already set up to eliminate each other. Right? And so let's add the rest of it together. So 280 plus 200 is 480. And then P plus P is 2P. And then let's divide by 2. So P equals 480 divided by 2 is 240. 240 what?
Miles per hour.
Yeah, miles per hour, right? We're talking about the speed of the plane, right? So 400 miles an hour is speed of plane. Okay, now how am I going to find the wind speed?
You can just plug in the 240 to the 7-hour equation.
Yeah, yep, you can put it into either one there, right? You can actually, put it right in here. So I say P is 240. I could just put 240 in there or into the other one, right? Or I could put it up here into this one. Later on in math, it's going to matter, like you're going to always want to go back to that original equation. On the ones that we're doing in this class, it's not going to matter if you, solved it like this and found an equivalent equation there. But let's just, put it back up into that original one so we remember here. So I've got 1400 equals 7 times 240 minus W. All right, and then I get 1400 equals, let's see, what's 7 times 240? It's going to be 1440. What is that? I don't have my calculator handy. Yeah, 1440. Yeah. Sorry, I'm losing. And then minus 7W, so I'll subtract the 1440 over. So I get negative 40 equals, whoops, wait a minute, I did not do that right. 14, that should not be there.
I got 1,680.
Yeah, you are right. 1,680. Thank you. And so then that's going to give me, so let's see, did I do this right? 120, no, I'm sorry, I am struggling here. I can't even read my own handwriting. So I've got 8 equals negative, whoops, yeah, and this should be negative. And then if I divide by negative 7, I should get W equals 40. So again, that's 40 miles per hour, and that's the wind speed. Okay, so wind speed is 40, plane speed is 240. If your wind speed turns out to be more than your plane speed, you've got a problem, because the plane would not be flying if your wind speed is more than the plane speed. So just double check to make sure on these, like, your answers make sense, right? Neither of those should come up to be negative. So if you came up with a negative answer, look back in your work and see, like, what, where you could have made a mistake and stuff. Just make sure that they make sense for the problem that you're dealing with. Okay. All right. Well, is there anything else that you thought of as we were kind of working through things that you had questions about that you wanted to ask about before we close up today?
Not me.
I have a question, but it's unrelated to the next exam.
Okay.
I have a question about for the next exam for scheduling. So I'm not sure if I can make it on that Wednesday, Thursday time frame, and I don't know if I can get a proctor for those 2 days. Is there any way I can reschedule that, or
Why don't you send me a message about that, and we can figure out what to have you do, whether to come and take it early or something like that. We can figure out something for you. Okay?
Okay, perfect. Thank you so much.
Yeah, of course. Anybody else? Thanks for being here. I hope this was helpful for you, and I just think you guys are going to do great on the exam. So just, finish studying up for this, and, reach out to me as you're going through this, getting ready for the exam. If there was anything else that you're like, oh, I found something I have a question with, all right? I'm here to help you if you need some help. So, all right, you guys have a great night. And
Thanks, Professor.
of course, we'll talk to you later.
Thank you so much.
Okay, of course. Good night.
Good night.
Could we go over another question
Sure.
you asked?
Yeah.
Okay.
What question would you like to go over? And how do you say your name? Ikran? Say it again.
Ikran?
Ikran. Okay, I thought that's how it was, but I wanted to make sure I was saying it right.
Could we go over one of the questions that are talking about? It's like an application problem. It's like the chemist needs to make 2 liters of a 15% acid solution.
If I tell you there's not going to be one like that on the exam, do you still want to go through it? I mean, we can, but
No, it's like
I'll give you that hint that you won't. But in your next class in Math 1010, definitely those kind of questions show up on the exam. So, but yeah, in this class they rarely do, and I can tell you they're not going to be on this exam for sure. Okay.
Thank you.
You're so welcome.
Have a good night.
You too. Good night.
Bye.
Did you have a question, Annabelle?